Welcome all to the session of Fortifying Security of AWS EKS, Elastic Kubernetes Services. I'm quite excited to be in this session with a very interesting topic of security. Before we moving on, I would like to know who are from DevOps or SRE background. Can you please raise your hands? Great. And is anyone from security background? Great. Only few hands, but still great. Thank you. Yeah. I structured the session with taking you through a real security incident of an application which was deployed in EKS. As a company, how we helped them to fortify the security of EKS platform and its details. Let's move on. Yes. Today I'm going to take through a leading heavy construction equipment company who has a fleet of excavators, loaders, dumpers, cranes, etc. These devices supports the local or domestic requirements as in the large, smaller capacity, as well as the large constructions and many of those aspects. These applications sends the data to the application stack, which is our focus area, and the different users uses this application. The CXO uses this application to get the stack, the entire set of their assets when talking to its customers. The billing department uses this application to bill the end customers based on the number of days it has been with any customers. And the maintenance team uses this application very high. They uses this information from these devices. They do predictive analysis for failures. And if they identify the failures, they talk to the vendors with the right set of information, reduce the breakdown of the system, ultimately reducing the breakdowns, ultimately improving the efficiency. Right. Yes, this is a quick architecture of these applications. All these equipments sends the data as an IoT to this application. And our application is designed and developed and microservices architecture and deployed in EKS. This application also uses different AWS services, its functions. In the application or in the Kubernetes, it has been isolated, subdivided into namespaces to accommodate more applications. There are two production namespaces which you can see, machinery prod and reporting prod, which are being using by two different businesses of this customer. And the third set of application or the namespace which was not there in this diagram, it's nothing but a development where the customer was experimenting with a lot of new features. This is how the data flow happens for the application. It goes, the streaming pod or the container is the one that authenticates the data, and the data management platform or the pod is the one that processes the data, and it stores the master database. Yes, those are the producers. Now the consumers are the businesses. They use this application this is a web application. It uses the front-end layer, which is nothing but the web UI, and the platform pod is the one does all the business functions. It gets the data from the master database and the metadata, and it creates or generates the custom page for the customer. Yes. Everything was good. The application was great. The business was flourishing, and the criticality of this application has become so high. During a normal operations, the team was really busy with their day-to-day activities. While in that, they identified an unknown pod or a container in the reporting namespace. Started to figuring out who was deployed this, what services it is exposing to the external world. They started deleting also the unknown, but it not went. Within no time, this particular namespace resource got expanded. The utilization of this namespace got high. Within no time, it started pressurizing, resource pressuring for the other namespace. Eventually, brought up performance problem for the end customers. The website was slow. There was an intermittent data loss from the IoT devices, the machineries. And short while, this stopped working. A complete breakdown of the application. And it is due to resource exhaustion attack. The other namespace utilized all the resources of this and it stopped completely. While team was busy on recovering it from the security incident, the team encountered another surprise. The master database, where most of the data is gone. There was a lot of data got deleted. A data loss attack, 2 attacks. Team started figuring out, how do I resolve from these problems? By the way, has any of your application had any security incident in EKS or in containers? Fortunately, unfortunately, no. Great, yes, this is the real incident, by the way, yes. Now, the team started figuring out, how do I resolve this problem? What was the cause of the problem? That is where the most interesting thing came out of this picture. The security team mentioned that I laid everything great. I put the principle of least privileges. I had all the security controls, but he was clueless. The authentication or authorization in Kubernetes is done RBAC, role-based access control. Similarly, the SRE said he patched everything well. He configured everything as per the best practices, but he never knew if the code has any arbitrary. Similarly, the DevOps engineer. She was good, she was done everything from the software lifecycle, all the code reviews, everything went well, but she assumed this will be done by a security team. The key takeaway of this was, key takeaway of this discussion was, there's no proper ownership, number one. Number two is very crucial. Everyone in this organization has their role to play in securing the platform, the workload, thereby the data. It's not a single team's responsibility, or it's not just one tool or a configuration that makes secure. And our journey started here. Where do we start? Can I deploy some firewalls, which we all knows it? Or can I encrypt the file system? Will that able to help securing this platform? Do anybody wanted to give an answer of that? Oh, okay, great. Yes, that's not. All these are one controls that will not give a comprehensive coverage. And what we really need, it's not just one. For the entire application, what you are building or what you are managing, what you really need is a comprehensive coverage. Right. The first thing that we started with, how do we start? Yes, we need something called as a framework. A framework that gives a comprehensive, standard and best practices that looks security from all the angles, that reduces risk to the environment. We have some things to start with. The first thing we have used is AWS well-architected framework security pillar. Probably you all know in a different fashion. Yes. This security pillar of AWS, which is well known, being developed or behind the scene, it uses 3 principles of cybersecurity. It's called protect, detect, and recover. And what you see here are 5 different sub-pillars or sub-domains of security. And the key topic or the key takeaway of this slide is, when we say EKS or Elastic Kubernetes Services, the security is, or the comprehensive security is, a combination of AWS native services and Kubernetes features. This is the one that gives a comprehensive coverage for securing the platform. Let's see. The first and foremost layer is IAM, Identity and Access Management, the key layer. In any security event, the first thing that gets badly configured is this layer. And when the security also, the pillar also, this is the first layer. When we say IAM, it does 2 functions. First one is authentication. It validates your credentials and checks, are you the right person or not? And second is authorization, which means it checks the permissions. It validates your permission, what you're supposed to have. The key factor in EKS. This is done by a combination of 2 services. Identification or authentication is done by AWS IAM, whereas authorization is done by Kubernetes RBAC, role-based access control. That's a difference in EKS. 1. Here, when we say IAM, there are 2 components. First one is human account or human identity. The second is service account which used by services, we'll see that. When we see human identities, right, the customer already had employed some of the great practices. Every user accounts had individual user accounts. Every user had individual user accounts, and they were given the least privilege, the principle of least privilege. They were given access to S3. They were given access to Aurora being the database. They were given access to ECR. But they were never given access to other services which they are not given. So the principle of least privilege, giving the right permission to do the right job, was already employed. Then what's the funda? That's what here. The RBAC, right? When we looked into the system, the IAM was perfectly configured, but the authorization system was this. What does it indicate is the DevOps engineer who was responsible for machinery namespace had access to the other namespace as well, which is not right. We need to fine tune it. What is the first thing we need to know it? It's called as principle of least privilege, give the right permission to the right people. The first thing we employed is something called as cluster role, which is a feature of Kubernetes, if you are aware of it. Kubernetes, this is nothing special, it is only the permission level. The permission in Kubernetes is done by roles and cluster roles. The first what we employed or leveraged is cluster role. Cluster role, it gives the permission across the namespaces within the cluster. So which is needed for our SRE team who actually works across the namespaces. Second, how did this work? If you can say this, the cluster role, nothing but the permission, gets cluster role binding, nothing but it associates the permissions with AWS IAM role, which is assumed or it will be assumed by the SRE team, right? Again, a combination of two people in authentication layer. Second, the role. This is the next level of services or capability of Kubernetes, which we leveraged. This is done for the DevOps engineer. The DevOps engineers are usually the one who will manage one or a set of namespaces, not across the namespaces. The same terminology or methodology has been deployed here. This is an example of roles which has been deployed for an L1 engineer in this namespace. Key pointers here, this is defined at the namespace level. Second, there are the services, for example, delete, updates. These are the set of actions that usually don't need for an L1 engineer, which we removed. Again, the principle of least privilege is something we defined it. With this set of changes, what we have employed here is giving the right permission to the right people, reducing the attack surface. Second, service account, the key aspect. The service account is the one that uses by any pod or any container when it is talking to AWS services. And this is how by default it works. Hope you're aware of this. Any pod uses the node policy. It uses the node policy while accessing any services out of this. And you can just view this node policy which was configured. It had full control of S3, RDS and ECR. I did not need it. Can you now relate how did the security event happen? When a pod, when a container, an unknown container got into this namespace, he blindly got access or he got a large access to the whole file system or whole services. So he can just walk around and get any services. Isn't it so challenging? Right? We need to scrutinize it. Again, what is needed for each pod is a principle that needs to be applied. How did we do that? Right. It's called IRSA. It's a feature which was developed by AWS for Kubernetes. It's nothing but, again, the amalgamation of a role or service account from Kubernetes that is mapping to the roles of AWS. One difference compared to the previous way. In this, the role permissions is AWS. In the other one, the permission sets are from Kubernetes level. Right. The first action what we did for the services or the pods or the containers that needs to talk, we defined dedicated service accounts. So once we created the service account, we imbibed or we configured that in the specific YAML file or manifest. What does that finally concludes as? The services or the pods or the containers which needs to talk to relative services have the specific configuration, service account configured, right? This reduces the blast attack radius, right? Which means tomorrow, in case if there is a new pod gets into the system, knowingly or unknowingly, will not have large permission sets that can go and do any challenges to your Kubernetes sets. Does anyone implement IRSA in your system? Oh, great, great. I've seen a system which did not have this, and this is one of the cases, and this is what happened, right? Yes, great. Let's move, let's shift our gear. The next production is infrastructure. What do we do to do product and infrastructure? This has three components which is getting layered. The first is ECR protection or the container registry. Container registry is nothing but the storage layer or storage subsystem where your images are getting stored. And this is how the workflow happens. When the SRE or DevOps engineer pushes the images, right? Images get scanned and it's been part of the repository. And these images get pulled as your containers. This, we validated some of the best practices customer already employed, and we reconfigured those with some of the best practices. The first two is the one which we employed. The first is the endpoints. By default, the endpoint is public, right? Even though it's a private registry, the URL is public. You can access from anywhere. That we configured with VPC endpoint so that the blast radius within your the access will be limited to your VPC. The second, the enhanced scanning capability. This is a feature of ECR that protects you from the common vulnerabilities, operating system layer challenges in your images, and it goes to the framework layer, the application framework layer, right? The other still the key features, I'm just going away. The cluster protection is the next key feature. When we say cluster protection, the major aspect here is a lot of heavy lifting on EKS is done by AWS. But still, we have a lot of stuff to do here to secure it, right? Yes, the team already had considered some of the best practices like using the updated version of Kubernetes and optimized armies for their node groups and a lot more. What we initially done to make it so crucial is the first two things, keeping the cluster endpoint as private. Are you aware that when you create a cluster endpoint, I mean EKS cluster endpoint, by default it is public. It is accessed from anywhere internet. It needs an authentication. But when your authentication system is compromised, this is going to be a simple cakewalk for any intruders to get into your layer. It can get into your EKS system, it can tamper your entire containers, right? So move into endpoint into private reduces the blast radius and resource quotas, right? This helps you prevent from your noisy neighbors. Pod security is another key aspect. We see that. The interesting point here is when a pod or a container get instantiated, by default, it runs in root mode, which means though it is within constraint of the pod or the container, it has the root privilege, which has a potential of moving away from its namespace, get into the node, which is your EC2 instances, and it can get all the access that system has it, right? This is scrutinized with something called as PSS, pod security standard, defining certain standard that a pod should have. This is implemented using PSS, right? The interesting fact, when an EKS is shipped, it is coming with the highest mode. There's no security for a pod. You can deploy simply, it just runs as a thing. We reconfigured it something called as a restricted mode, which enforces certain standards, security standards for all pod. What are they? This is the one. It ensures that your pod has certain standards when it deploys, ultimately reducing its root usage, right? I'll just go quickly. And the same methodology with lot more flexibility, you can use policy as a code feature. by default, a network space, right? Kubernetes or EKS network space works in this fashion. I hope you are aware of this. Any pod, any container within the namespace, within the EKS can simply talk to each other. This is what it is, right? This has two challenges. One, it gives an additional network surface. The network exposure is so huge in this. Now you can recall, how did the security happen? A system that got here simply could go away and get into a different network, right? This needs to be scrutinized. Need two separate aspects here. One is pod-to-pod security, right? This implemented using something called as Kubernetes network policy, right? For Kubernetes network policy, it starts with default deny policy. When we did default deny, this is what happens. Your namespace get complete fine-grained. No except namespace level access is there. Once this has been set up, you do a relative required namespace pod level security policies. And this is an example of that. What does it mean? This is for the platform pod. This is where it is. This is saying only the connection from front-end pod is allowed on port 8080, which is just put it in the red to identify it, right? With this, what are we doing? We are securing at the pod level. Now the next access is external access. Again, when it goes external to the AWS services, we need to do the same level of security. What do we do that? The well-known EC2 security group, right? You can configure or you can leverage those security group in the pod configuration. I'll quickly move on. In the interest of time, sorry for that, right? The next key features is detective control, right? What we've seen so far is protective control, that is to protect your systems. Now, in the security life cycle, detection also has the same level of priority as protection. What it indicates, it checks your EKS systems, it checks the anomalies, then it validates and gives you. The key aspect here is guard duty. It's a feature or it's a service from AWS, a threat intelligence service from AWS that actually checks the logs, checks all your action, and it can predict if there is an anomaly based on where it is action, the sequence of action, the sequence of APIs that is being executed. Now, the guard duty got extended capability by looking through the logs of EKS. Right? All the EKS logs, which means all your APIs, action, creating a pod, deleting a pod, configuration, all the changes, your API action, Kubernetes API action, can be configured to monitor by EKS. It has got 35 unique capability that can go ahead and checks the logs for credential access, network access, and it can alert you if something is going wrong. Similarly, runtime monitoring, another key feature which AWS EKS guard duty got created. That's nothing but in 2023, that's the one. What it do? The protection has moved from the cluster level to the pods and the nodes level. What it exactly do? It checks your containers, it checks your nodes, and it checks if any nodes or container is trying to do a file access. It is trying to create a new process which is trying to exfiltrate the data and the network access. All the runtime events will be monitored and it alerts you. Our case, the customer had already used the guard duty, but the capability, the special capability of guard duty, the feature was not enabled, which we did that immediately. The second major thing was control plane login. It's nothing but it is a feature of CloudWatch logs. Right? CloudWatch is a well-known from all observability capability that got extended capability for EKS as well. Simply all the logs, EKS logs can be pushed to the CloudWatch logs. Again, what we have done on this case is customer already considered CloudWatch control plane login monitoring. We extended that to node and container level. All the logs, consolidating logs will be sent to CloudWatch logs, and what we have additionally did is we have configured specific events by filtering those to see if a critical activities like deletion, continuous denial, right? All these we have configured to prevent it. Right. These are the key takeaways I would like to part of this session. The first is very key aspect. It's a critical takeaway. Security is a collective responsibility. It's not a person. Be it an admin, be it a developer, be it an architect. You have a role to play, and these knowledges are the one that helps you to do this stuff. It's not just one team's responsibility. Principle of least privilege, to give the permission. System masters, probably if you were to work in EKS, system masters is a role that EKS developed on top of the Kubernetes, and giving that highest privilege will compromise all your systems. Right. Thank you. Thanks a lot.
Thank you, Karthik. Thank you for that session. Let me invite Neha to present the gift to Karthik. Can we have a big round of applause for Karthik?
He's so shy.
Okay. ഇത് എങ്ങനെയാണ് ഇത് നെക്സ്റ്റ്
Let's start again.
Thank you, sir.
Okay.
So please